Dear students, my name is Lakshman. I am working as an assistant professor in the Department of Pharmaceutical Chemistry and Medicinal Chemistry in Raghavendra Institute of Pharmaceutical Education and Research in Anantapur. So today's our topic is that benzene, the orientation effect in benzene. Okay, this orientation effect we are mainly going to be seen in monosubstituted benzenes. The orientation effect. Coming to the orientation effect in monosubstituted benzenes, this actually the benzene ring which is going to undergo the chemical reaction, that is electrophilic aromatic substitution reactions. Okay. Benzene undergoes electrophilic aromatic substitution reactions. Simply called as EPS reactions. So what is the meaning of electrophilic aromatic substitution reactions? So first of all we are going to see that what is the meaning of substitution reaction. The substitution reaction means the reaction in which one group is substituted by another group. The reaction in which one group or atom is substituted by another group or another atom is called as substitution reaction. The reaction in which one group or one atom is substituted by another group or another atom is called as substitution reaction. Okay. So now what is the meaning of electrophilic? Okay. So here is what is the meaning of electrophile? Okay. Electrophile. Electrophile means what? Normally, the electron deficient species are called as electrophiles. Electron deficient species are called as electrophiles. Electron loving species. Electron loving species called as electrophiles. So these electrophiles are simply represented by E plus. Okay, because of this are having electron deficient species. Okay, this might be having the positive charge. Okay, that is the thing about electrophile definition and substitution reaction. Okay, now, so what is the meaning of electrophilic substitution reaction? Okay, the substitution reaction in which one electrophile is replaced by another electrophile, or the substitution reaction in which one group, the electrophilic substitution reaction means the substitution reaction in which attacking agent is electrophile is called as electrophilic substitution reaction. Okay, benzene and its derivatives undergoes the electrophilic substitution reactions, along with heterocyclic compounds also undergoes this electrophilic substitution reactions. The substitution reactions in which electrophiles act as attacking agent is called as electrophilic substitution reactions. So, in this electrophilic substitution reaction, attacking agent is electrophile. That is the most important form. Okay. So, what is the meaning of electrophile? Electron deficient species or electron loving species are called as electrophiles. Okay. So, which of the compounds will undergo the electrophilic aromatic substitution reactions? Nothing but benzene. Okay, benzene undergoes the electrophilic substitution reaction. Benzene derivatives. Okay, benzene derivatives also. Benzene derivatives like example is phenol. Next example is toluene. Okay, next anisole. Okay, also undergoes that is electrophilic substitution reactions. Okay, so polycyclic compounds also undergoes electrophilic substitution reactions or electrophilic aromatic substitution reaction. What are these polycyclic compounds? Nothing but naphthalene. Okay, phenanthrene. These compounds will undergo that is electrophilic aromatic substitution reaction. In addition to these compounds, the heterocyclic compounds also undergoes the electrophilic aromatic substitution reactions. Okay, what is the meaning of this heterocyclic compound? Nothing but the compounds which are having the other than carbon atoms at least one hetero atom. The compounds which are having the at least one hetero atom in addition to carbon atom is called as, those compounds are called as heterocyclic compound. Okay, what are the examples for heterocyclic compound? Famous example is that is furan. Okay, second example is pyrrole. Okay, third example is thiophene. And another example is that pyridine. Next example is that indole, very famous heterocyclic compound. Okay, so many compounds are there. Out of this, very famous compounds are furan, pyrrole, thiophene, and pyridine is there, indole. This all are the compounds which will undergo the chemical reaction that is called as electrophilic aromatic substitution reactions, simply called as EPS reactions. Okay, that is the EPS reactions. This is very important. Okay, if you wanted to know the chemical reaction of a specific compound, then you have to know that compound will undergo which type of the reactions. That is the most important. So benzene derivatives, polycyclic compounds, heterocyclic compounds, this all the compounds undergoes the electrophilic aromatic substitution reactions. Orientation effect means the group which is already present on benzene ring is orients the upcoming or incoming group is called as orientation effect. The group which is already present on the benzene ring decides the position of orientation of incoming group, that is called as orientation effect. The group which is already present on benzene ring orients the incoming group. Orients the incoming group position on benzene ring is called as orientation effect. Okay, normally the groups are two types. Okay, the groups are two types. First and foremost group which is there, that is called as the groups are two types mainly. Okay, first and foremost is called as ring activating groups. Okay, second one is called as ring deactivating groups. Ring activating groups and ring deactivating groups. These are very important concepts. Okay, this orientation effect on monosubstituted benzene is very important. Very important. Okay, for GPAT, it is very important for GPAT and NIPER JEE. Okay, and regular university exams also it is very important. Okay, most famous compound orientation effect in monosubstituted benzenes. Okay, so the groups are two types, ring activating groups and ring deactivating groups. We'll see in detail about what are the examples, what is the meaning of ring activating groups and ring deactivating groups. Okay, what is their definition and how they are classified. That is the straightforward question was given in GPAT and NIPER JEE. Okay, that's the reason we are going to discuss. The groups which activates the benzene ring is called as ring activating groups. The groups which reduces the activity of benzene ring is called as the ring deactivating groups. Okay, so always if you are looking on any benzene ring, definitely you might be find ring activating groups or ring deactivating groups. Okay, so ring activating groups and deactivating groups are very important. Okay, in organic chemistry and in medicinal chemistry also. Yes, first we'll focus on ring activating groups. Ring activating groups. So coming to ring activating groups, okay, the groups which activates the benzene ring is called as ring activating groups. The groups which activates the benzene ring, is called as ring activating groups. Again, this ring activating groups are three types. So coming to the classification of ring activating groups, okay. So these are three types. Number one is that strong ring deactivators, moderately ring deactivators, weak ring deactivators. So here, coming to the classification of this ring activating groups, okay. First and foremost class is that strong ring activator. Strong ring activating groups. Okay, second one is moderately ring activating groups. Third one is weak ring activating groups. Okay, strong ring activating groups, moderately ring activating groups, and weak ring activating groups. Okay, that is the thing. So coming to this groups, okay, so here is that if the groups which are going to strongly activates the benzene ring is called as strong ring activating groups. If the groups which are going to moderately activates the benzene ring is called as moderately ring activating groups. If the groups which are going to weakly activates the benzene ring is called as weak ring activating groups. Okay. Now, so the ring activating groups, which groups can act as ring activating groups? Nothing but the electron donating groups can act as ring activators, or electron releasing groups can act as ring activators. Okay, electron releasing groups or electron donating groups can act as ring activating groups. the electron donating groups or electron releasing groups can act as ring activating groups. Okay. Now, the strong electron donating groups can act as strong ring activating groups. The moderate electron donating groups can act as, that is, moderate ring activating groups. Okay. Weak electron donating groups can act as weak ring activating groups. Okay. That is the thing. Okay. So electron donating group is simply represented by EDZ. EDZ nothing but electron donating groups. Okay, and this electron donating group also called as electron releasing group, ERG. Okay, so in textbook you might be find the term that is EDZ or ERG, both are same. No need to be worry about it. That is not a different words, those are synonyms. Okay, that is the some concept. What is the meaning of this ring activating groups? Let us will take the examples. Let us will see the examples. So that is, we are going to see that ring activating groups examples. Ring activating. Ring activating groups examples. Okay, very very important. Straightforward question was given in GPAT and Hyper JEE. Okay, so coming to this, what is the first and foremost is that strong ring activating groups. Strong ring activating groups. Okay. Strong ring activating groups are very famous and very important. Very simple examples. Okay. Now, the example is that first and foremost example is OH. Okay. Hydroxy group. Hydroxy group, which can act as first and foremost example. Okay, hydroxy group. Okay, second example is OCH3. Okay, that is called as methoxy. Okay, second example is methoxy group. Okay, third example is OC2H5, that is ethoxy group. Ethoxy group. Okay, ethoxy group. Next one is amine group. Okay, NH2, simply called as amine group. Amine group. Okay, next one is that NHR. This is called as primary amine. Why it is called as primary amine? Because of the presence of only one alkyl group, this compound is called as primary amine. Okay, now so this is called as secondary amine. Okay, this is called as secondary amine. So this all these compounds can act as strong ring activating groups. Okay, all these compounds can act as strong ring activating groups. Okay, so that is the thing. Now, in this, why these compounds can act as strong ring activating groups? Nothing but these compounds can act as strong electron donating groups. Okay, these are strong electron donating groups. Strong electron donating groups. Okay, EDZ. Or strong electron releasing groups, or strong electron releasing groups. Okay, that means ERG. Okay, ERG nothing but electron releasing groups. EDC nothing but electron donating groups. Both are same. Okay, because of these compounds can act as strong electron donating groups or strong electron releasing groups. That's when these compounds can act as strong ring activating groups. Strong ring activating groups. Okay, so these compounds we are going to be there. These compounds, why these compounds can act as electron donating group? Nothing but because of the presence of lone pair of electrons on these compounds. These compounds can act as strong electron donating groups. Okay, because because of the presence of lone pair of electrons. Lone pair of electrons. Okay. Because of the presence of lone pair of electrons on this oxygen atom or nitrogen atom, that's when these compounds are strongly, quickly, readily donates the electron. That's when these compounds are called as strong electron donating groups. Okay, these are very, very important groups. Okay, so why these compounds are a electron donating group? Why not electron withdrawing group? Because of the presence of lone pair of electrons. On oxygen, 2 lone pair of electrons. Okay, on nitrogen, 1 lone pair of electrons is there. So that is the reason. Okay, next is examples for moderately ring activating groups. Okay, or moderate electron donating groups or moderate electron releasing groups. Okay, what is the thing? That means these compounds, the groups which are going to little bit, okay, so these groups which are going to slowly donates the electrons is called as moderate ring activating groups. Okay, that is the thing. So the groups which are moderately activates the benzene ring is called as moderate ring activating groups. Okay, now what is the examples? Okay, this is the compound. So another compound is oxygen C double bond O CH3. Okay, another compound is C double bond O pH, nothing but phenyl group. Okay, another example is that NH C double bond O H. Okay, next example is NH C double bond O CH3. Okay, another example is NH C double bond O pH. Okay, so these compounds, okay, these compounds can act as all these compounds can act as, that is moderately electron donating groups. Moderately electron donating groups, or moderately, or this compounds can act as moderately electron releasing groups. Moderately electron releasing groups. Okay, that is the thing. So these compounds, okay, here this one is indicates that the point of attachment to benzene ring. This is indicates that the point of attachment to benzene ring. Okay, here only these compounds are going to be attached. Okay, so here if you are going to look at this, here you can find that electron donating groups are there. Okay, which are having the excessive electrons. So here you are having that nitrogen which is having the excessive electrons. Nitrogen, okay, which is having the excessive electrons. Nitrogen which is having the lone pair of electrons. Like that is there. Because of the presence of lone pair of electron on oxygen and nitrogen, so these compounds are going to act as the electron donating group. Why these compounds can act as moderate electron donating groups? Nothing but C double bond OH is can act as, or C double bond O CH3 or C double bond O pH can act as, this fragment can act as electron withdrawing group. Okay, this fragment can act as electron withdrawing group, but this fragment can act as electron donating group. If electron donating group is straightly or directly attached to benzene ring here, okay, for that electron donating group, here is electron withdrawing group is attached, so that the impact of electron withdrawing group on benzene ring is little bit. That's when these compounds can act as moderate electron donating groups. These compounds can act as moderate electron releasing groups. That's when these compounds are going to be this. All these groups can moderately activates the benzene ring, not strongly, only moderately. Okay. So this is the thing. These are the examples for moderate ring activating groups. Okay. The groups which weakly activates the benzene ring is called as weak ring activating groups. Okay. The groups which weakly, okay, weakly activates the benzene ring, weakly activates the benzene ring is called as weak ring activating groups. Weak ring activating groups. Weak ring activating groups. Okay, which is weakly activates the, that is benzene ring, weakly activates the benzene ring. What are the examples? Simple examples. Okay, simple examples is that alkyl groups. Okay, or that means alkyl groups. Okay, so here is, what are the alkyl groups? Methyl group it might be. Okay, methyl group, or this compound might be ethyl group. Okay, ethyl group or phenyl group. Okay, or C6H5, that is phenyl groups. Okay, phenyl group. So these three groups, these are the groups which can act as, okay, which can act as weak electron donors, weak electron donating groups. Okay, weak electron donating groups or releasing groups, or weak electron releasing groups. Okay, because of why these compounds are weak electron donating groups? Because of, okay, there is these compounds or this group do not having, these compounds or these groups do not having lone pair of electrons. This compound do not having lone pair of electrons. That is the reason these compounds can act as weak ring activating groups. Up to some extent only these groups are going to activate the ring. Methyl group, ethyl group and phenyl group. Okay. Anywhere, if these groups are present on benzene, nothing but these compounds are weak electron donating groups. Okay. That is the thing. Now we are going to discuss, that is ring deactivating groups. Ring deactivators. So coming to ring deactivators, the groups which are going to reduces the activity of benzene ring is called as ring deactivators. Okay. The electron withdrawing groups can act as ring deactivators. The electron withdrawing groups can act as ring deactivators. So coming to the classification of this ring deactivators. Okay, classification of ring deactivating groups. So this is classified into three types. First and foremost, that is called as strong ring deactivators, moderate ring deactivators, third one is weak ring deactivators. These are the three classification of ring deactivating groups. Ring deactivating groups are classified into three types: strong ring deactivators, moderate ring deactivators, weak ring deactivators. These are the three types. Okay, so here is this ring deactivators decreases the activity of benzene ring. Okay, decreases the activity of benzene ring. The electron withdrawing groups, okay, electron withdrawing groups, that means EWZ nothing but electron withdrawing groups can act as ring deactivators. These are three types. Okay, these are three types. Let us will see what is the examples for these compounds. Let us will see. Yes, we are going to see that strong ring deactivating groups. Strong ring deactivators. Okay, so the groups which are going to strongly reduces the activity of benzene ring is called as strong ring deactivators. The groups which are reduces the activity of strongly reduces the activity of benzene ring is called as strong ring deactivators. What is the example? So coming to the example for these compounds. Okay, first and foremost thing is that nitro group. Second one is that cyanide group. Third one is that SO3H. Okay, that is sulfonyl group. Sulfonyl group. Next one is that carbon trifluoride. Okay, carbon trifluoride. This group also can act as strong ring deactivating group. Carbon trichloride. Carbon trichloride. This group also can act as strong ring deactivating groups. How these groups can act as strong ring deactivating groups? Nothing but all these compounds which are having okay, strong, which can act as, okay, this all the compounds which can act as strong electron withdrawing group. Strong electron withdrawing group. Strong electron withdrawing groups. EWZ. Okay, so that these compounds can act as, because of these compounds can act as strong electron withdrawing group, so that these compounds can act as, that is strong ring deactivators. Strong ring deactivators. Strong ring deactivators. Okay, so that is the thing. Now this compounds, nitro group is there and cyanide group is there, SO3H is there and carbon trifluoride and carbon trichloride. Okay, so this indicates that point of attachment. Okay, so if this compounds going to be attached to benzene ring, then these compounds can act as, that is, ring deactivators. The activity of benzene ring going to be reduced by using these compounds strongly. That's when all these compounds can act as strong ring deactivators. Okay, strong ring deactivators. Next, second class of ring deactivators is moderate ring deactivators. Moderate ring deactivators. Okay, these are the compounds, moderate ring deactivators. Okay, so coming to moderate ring deactivators. Okay, the groups which are going to be moderately reduces the activity of a benzene ring is called as moderate ring deactivators. Moderate ring deactivators. Okay, so what are the examples? Okay, so coming to the examples, very famous example, C double bond OH or CHO also correct, which is called as aldehyde. Okay, which is called as aldehyde. Okay, next, C double bond O CS3, which is a ketone. Okay, which is a ketone. Okay, now, so here is C double bond O pH. Okay, this is the compound. And next one is C double bond O OH, which is a carboxylic acid. Okay, carboxylic acid, which is a carboxylic acid. Okay, next, C double bond O OCS3, which is called as ester. Okay, now, so here is that C double bond O NH2, that is amides. Okay, C double bond O NH2, that is a amides. Okay, and this all these compounds can act as moderate ring deactivators. How we can find that these are moderate ring deactivators? Now here we can say that this is the point of attachment. Okay, point of attachment. So at this point only this compounds going to be attached to the benzene rings. Okay, whenever these compounds are going to be attached to the benzene ring, okay, these compounds are moderately act as moderate electron withdrawing groups. Moderate electron withdrawing groups. Okay, EWG. That's the reason these compounds can act as moderate ring deactivators. Okay, if these compounds which are present on the benzene ring, then definitely these compounds can act as ring deactivators. For example, if benzaldehyde is there, okay, in this C double bond OH is present. Because of the presence of this compound, okay, this compound can act as ring deactivators. Okay, now, so this, whatever this group which is present, aldehyde group in this benzaldehyde, that is going to be reduces the activity of this benzene ring, which is going to reduces the activity of this benzene ring. Okay, this is about moderate ring deactivators, aldehydes, ketones and substituted ketones and carboxylic acids, esters, amides and acid halides also. Okay, so C double bond OH, that is called as acid halides. This acid halides also belongs to moderate ring deactivators, because these compounds or these groups are going to withdraw the electrons from the benzene ring, from the aromatic ring. That's when these compounds can act as moderate ring deactivators. And in these compounds, okay, there is no lone pair of electron. See here, beside to the point of attachment, okay, the carbon atom is attached. Carbon atom Okay, carbon atom which is attached. So carbon atom do not having the any lone pair of electrons. Okay, carbon atom is a electropositive atom. It is this carbon atom do not having the any lone pair of electron. That's reason it do not donates the electrons. Okay, so here is that this all these compounds can act as moderate ring deactivators. Okay, now weak ring deactivators. Okay, weak ring deactivators. Now coming to the weak ring deactivators. Okay, the ring deactivators are the groups which are going to very less, the groups which are going to very less tendency to reduce the activity of a benzene ring is called as weak ring deactivating groups. The groups which are having the tendency to reduce, very less tendency to reduce the activity of a benzene ring is called as weak ring deactivators. Okay, what is the examples? What is the examples? Okay, example is fluorine, chlorine, bromine and iodine. Okay, so this all the groups which are belongs to, okay, which are belongs to halogens, which are belongs to halogens, that means X. Okay, halogens. So these compounds having the, okay, these compounds are having the weak electron withdrawing, these all are can act as weak electron withdrawing groups. Okay, EWG, electron withdrawing group. In that also very weak electron withdrawing groups. Okay, that's in this all these compounds can act as weak ring deactivators. Okay, that is the thing. Fluoro, chloro, bromo, iodo. This all halogens can act as weak ring deactivators. Halogens can act as weak ring deactivators. Okay. So here the point is all ring activators. Okay, all ring activators, nothing but it might be strong, okay, or it might be weak, or it might be moderate. Okay, ring activators, either they might be strong ring activators, weak ring activators, moderate ring activators, plus weak ring deactivators. Okay, that means halogens. Okay, halogens, that means halogens can act as, okay, can act as ortho para directors, act as ortho para directors, which can act as ortho para directors. Okay, so that is very important point. All ring activators and weak ring deactivators. Okay, so all ring activators and weak ring deactivators, that means halogens, okay, can act as ortho para directors. Okay, the direction, if already this all ring activators or weak ring deactivators was substituted on the benzene ring, then definitely upcoming group or incoming group will be oriented towards ortho or para directors. Okay, ortho or para direction. Okay, now, so all ring deactivators okay, all ring deactivators act as, so here all ring deactivators except weak ring deactivators, weak ring deactivators can act as all ring deactivators can act as that is the meta directors, okay, that is meta directors, okay. So meta directors now, so all ring deactivators can act as except weak ring deactivators can act as meta directors, okay. So all ring activators and weak ring deactivators going to be increases the, okay, electron density at ortho and para position, okay. But all ring deactivators except weak ring deactivators can increases the electron density at meta direction, okay, at meta position. That is a very very important point. It was given in the GPAT and Hyper JEE so many times, okay. And regular university examinations, they might be also give in the point of view of regular university examinations along with that is online examinations. Must and should you have to remember this point, okay. Most famous point. So many times it might be used, okay, by you during the research in chemistry also you can use, okay. That is the thing.